We have published a paper together. He's one of my favorite researchers in the web application security space. And if you have not read his paper from last year on script inclusion, it's called "You Are What You Include." You really need to check that out. It's all about hot linking scripts and how the web actually looks in that sense. But now it's time for web fingerprinting. The stage is yours.
Yeah? Okay. Thank you very much for your kind words. So yes, my name is Mikkel Giforakis. So thank you very much for being here. I am, as John said, almost done, but it somehow sounds better to say final year. I'm working mainly on web security and privacy, and what I like to do is I like to identify online ecosystems that people haven't analyzed, and I sort of try to look at them systematically and identify what are the players involved, how do they interact, search for common patterns across ecosystems, and then also search for systematic problems in them. So this talk is a bit of an ecosystem talk, so do keep that in mind when you're looking at the slides. I'm sure you've seen such an image many times before. It's essentially just an article from the New York Times, and all the content that is highlighted with red is third-party content. So it means that it was not provided by the web servers of New York Times, but rather by some advertising networks, some social networks, and so on. And you know the problem with this, that when your web browser asks for resources from these third-party servers can also include cookies in their responses. And so if you have two sites that cooperate with the same advertising network, essentially the advertising network can track you across sites. So that's of course not really news, so that's not what I'm going to talk to you about today. But what you can do with these techniques is essentially third-party tracking. So we did a study last year, and among the top sites on the internet trusted for JavaScript were these companies right there, so like QuantServe, Scorecard Research, and AppThis, which are like sites that most users don't have a first-party relationship with. So it's doubtful that one of you went, typed quantserve.com and went browsing to their site, or Scorecard Research, and yet they are there among the top 10 providers of JavaScript on the web. And essentially what they are is that they are third-party trackers that companies are using, for example, for analytics or advertising, and they also gather your data and they can create profiles about you. So if you want, this is the paper that John mentioned. I would invite you to read it. I had fun time writing it. But this is not what we're going to talk to you about today. So today, I want just to tell you that tracking involves much more than third-party cookies. So if you're blocking cookies, if you're deleting cookies, that's not the end of the story. And essentially, fingerprinting, for the purposes of this talk, is the ability to tell users apart based on the browsing environments, without any extra stateful identifiers that you communicate to the client. What we did, this is a work from essentially published earlier this year. We did a thorough study of current fingerprinting practices on the web. So who are fingerprinting, why are they fingerprinting, how do they fingerprint, and so on. And we also inquired into how easy it is today, you as a user, to hide the true nature of your browser. And we found that it is very, very hard. So, as I said, cookies are out there, people know about them, so the situation today is not what it was a few years ago. So, according to a 2012 or 11 study by Comscore, 1 out of 3 users delete all their first-party and all their first and third-party cookies within a month after they've been set up. So, you have people who are knowledgeable now about cookies and go around deleting them. Then you have multiple extensions that reveal hidden trackers, like Ghostery and Collusion. And in case you don't know Ghostery, it's a great tool. So, see this little ghost up here? That tells you that on Stack Overflow, you have 4 trackers. So, AdZer, Google Analytics, PubMatic, and Quantcast. And some sites have more than others. So, I went to the first celebrity news site that I could find on Google, and you have 24 third-party trackers. So, essentially, all of these are just grabbing your data every time that you go there, and Ghostery gives you the ability to disable them or learn more information about the companies and so on. So Another one is Collusion from Mozilla. That's also a nice tool that visualizes third-party tracking networks. And you also have private modes in your browsers that can be used to avoid traces of cookies. So, you browse a little bit, you go out of private mode, you go back in, and there are no cookies left. However, that's not the end of the story, or I wouldn't be here talking to you. So what if I could tell you that today an interested party is able to track users without the need of cookies or any other stateful client-side identifiers. So I'm not talking about EverCookie here, where you just push a lot of values in various weird places. I'm talking about pushing no data to the user. And as a bonus, this is quite hidden from users, so there are no cookies for you to inspect and delete, and it's actually also quite hard to avoid it or opt out. And this is called web-based device fingerprinting, or in short, web fingerprinting. And this issue got a lot of attention in 2010 when a researcher from EFF, so Peter Eckersley, he showed that you can use certain attributes of your browsing environment, and if you combine them properly together, you create a fingerprint that is unique of that browsing environment. So let's see how he does that. He said, you come to my website, and I first ask your browser, what type of browser are you? Are you from Mozilla or Chrome or Google, Chrome and Safari? So you get the family, you get the version, you get some headers of what types of files you support, and then if JavaScript is enabled, which of course it is, you then go on to ask a few questions. So for instance, you ask, what is the width and the height of the user's screen, right? And this is a perfectly allowable operation because you may have a web application that needs to reflow things according to your width and height. Then you go on and say, please give me your current time zone, because again, you may think that this is something that's desirable. Then, in most browsers, you can still go on and say, please give me a list of your plugins. So, you would get Java and with its version, you would get Adobe Reader, Flash, what other plugins you have. And then the interesting thing is that some plugins, like Flash, like Java, they allow the programmer to ask a list of fonts on your machine. So Eckersley would use that, and he would get a list of fonts from your machine. And then he would also conduct some tests on super cookies. Can I use global storage? Can I use local storage? And so on. So what Eckersley found is that from about 500,000 users who participated in this experiment, that 94.2% of them could be uniquely identified when they had Flash or Java enabled. So what this means is that for the people that had Flash or Java, there were almost no two users that had completely identical environments. And he also showed that you could use simple heuristics to track updates. So today, if your browser would update and your user agent string would change to next version, I could still use all of the other attributes to figure out that, okay, it's still the same user, he just updated his browser, and know that it was you. So I ran this yesterday on this laptop from my hotel, and here you can see, you can also try it on your own if you want. It's panopticlick.eff.org. So here you see essentially, look, my user agent is this one. This contains 7.4 bits of identifying information, and only 1 in 168 browsers has exactly that signature. Okay, fair enough. Then this is the same for the accept headers. 1 in 32 browsers have identical accept headers. But then when you go to the list of plugins, which is this, then you see that these are revealing 20.66 bits of information, which means that, and according to his results, only 1 in 1.6 million users have an identical list of plugins like mine. So what this means is that no two browsing environments in 1,600,047 have the exactly same number of plugins and the exact same plugins. And if you continue on, you can see that, okay, time zone, 1 in 6 has this time zone, 1 in 17,000 has exactly the same screen size and color depth like my laptop. And then you go back to my list of fonts, which is quite machine specific. And again, only 1 in 1.6 million has such a list like mine. So you can understand that when you combine all this information together, let's just say that you just put everything in one string and you hash it, then this hash is quite specific of the user currently on your website. So you can imagine if you're a site with, let's say, 10,000, 100,000 visitors, how much of redundancy there is in identification in these bytes. So what are these, what is fingerprinting used for? And the first thing you can use it for is ads. So you go ahead, you delete your cookies, you delete your, your browsing history, no problem. I still know that it is you because I do not depend on cookies to know that it is you. Then something more positive, it can be used for anti-fraud. So you may have seen this already. If you travel to the other, to a completely different part of the world, and you try to access an account, then, for example, Facebook would say, yeah, you usually log in from Germany during the day, and now you're in Singapore and it's night, so I'm not sure if it's you or if someone has stolen your credentials and is trying to log in from wherever he is. So it's sort of like fingerprinting is used for anti-fraud, and then they would ask you a few more questions so that to make sure that it is you and not someone who has stolen your credentials. Then we have found that it is also used for paywalling. So you're an online newspaper, you want to give access to 10 articles, but not to an infinite number of articles. So you actually, you fingerprint the user, and when the counter hits 10, then he has to pay. And there are no cookies for him to delete and pretend that he's a new user. And finally, if you're catching up with recent news, there was an attack on the Tor network, which essentially brought down the Freedom Hosting, which was a hosting provider within the Tor network that was hosting shady and non-shady websites. And what was happening essentially is that this site was exploiting a vulnerability in an older version of the Tor browser. And then it was through shellcode, it was actually grabbing a few machine-specific values of the system and then sending these values out to a machine controlled by the attacker. And the most popular theory so far is that these were the feds that were doing this. For example, trying to figure out who is visiting child pornography sites that are on Tor, or the Silk Road, like the drug network that is on Tor. So this is, with the exception of the Tor stuff that I told you, we kind of knew that fingerprinting was going on, in 2012 when we started working on it, but there were some questions that begged answering from our perspective. So the question is, how is fingerprinting working today? So are people just copying what Eckersley did and just branding it as their own product? Could they be doing more if they wanted to? Who is using them? So which sites are clients of fingerprinters? And how are users trying to hide from fingerprinting? And if it is working, what they're doing? So this, again, being an academic, this is a paper where all of what I'm going to talk to you today is in, with much more. So if you like it, you can go ahead and read it. It's called Cookieless Monster, Exploring the Ecosystem of Web-Based Device Fingerprinting. So we started our analysis by finding out 3 companies that are quite large, and they just say we offer fingerprinting services, right? So these namely were Bluecava, ThreatMetrix, and iOvation. And the process that we followed is this one. So we first found the domains that they use to serve their JavaScript and Flash from. And then we found some websites that make use of these domains so that they remotely include code from these domains. And then we went in manually, we isolated the JavaScript code that was coming from these providers, we deobfuscated it, we analyzed it, and then we compared the code with each other and classified it together with what Eckersley had said back in 2010. So, as you can see, the deobfuscation part can take a while because these companies are not super eager to share their fingerprinting code with you. So the results is that essentially we were able to create a taxonomy of all fingerprinted features that each company is involved in. And what we could say is, for example, that collectively, panoptic was fully covered. So this is an example where the industry is reaching quite fast with academia, because they were not like ages behind on fingerprinting. No, they were really doing what Eckersley had done in 2010. And what we also found is that actually they were doing much more than what Eckersley was doing in 2010. So these are the layers of fingerprinting that we came up with in our taxonomy. So if you start from the top, your browser customizations can be fingerprinted. So what sort of plugins have you installed? What sort of extensions have you installed? Then you have browser-level user configuration. So what choices have you made within your, let's say, vanilla browser that are detectable? Then fingerprinting in the browser family and version, and then even on the operating system and applications and the hardware network. And the last two, if you've been following, if you've been paying attention, you're like thinking, okay, they're using JavaScript to fingerprinting, they're using Flash to fingerprinting, but none of the two has access to my hardware network. These things are sandboxed. And just pay attention and we'll see how they do this. So this is at least one new feature that these companies were fingerprinting as opposed to Eckersley. So for instance, they had a really long list of ActiveX class IDs, and they were probing your Internet Explorer one by one, simply because Internet Explorer does not willingly provide you with a list of plugins and toolbars installed on the user's browser. Then in the browser level user configuration, they were actually fingerprinting your do not track choice. So when you choose do not track a specific value, this becomes part of your fingerprint, which is an interesting thing. Then at the browser family and version level, they were actually checking math constants of your JavaScript environment. And our best theory so far is that essentially, if you have these long mathematical constants with a lot of floating point digits, that in some browser vendors, in specific architectures, some of the floating digits at the very end digits will be a bit different. So these could be used to sort of make sure of which browser they're running on. Then at the OS and application level, we found fingerprinting done of the Windows registry and even of TCP/IP parameters on hardware and network. So I'm going to talk to you about non-trivial extras, and you can read more in the paper if you're so inclined. So if you remember, Eckersley needed Flash or Java in order to get a list of fonts from your browser, simply because JavaScript doesn't give you such a list of fonts. So what we found is that essentially companies were able to do a non-plugin font detection just by using JavaScript. So how does this work? So the script does the following. It creates a specific string with a long font, with a big font face, and it says, please set it to Arial. And then it says, for the box around it, let's say the div that is around it, what is the width and the height of that div, right? And JavaScript replies, let's say just a number, yeah, it's 500 by 84. Great. Then they have a long list of fonts. Then they use the next font in that list. They create a new string, exactly the same string with the same font size, and then they ask again, what is the width and the height of this string, of the surrounding box? And of course, because of stylistic differences, you see here that this thing is longer than the Arial. So they get a number that is different than the Arial font face. And now they know that, okay, the font face is there, it was used to render the text, and that's why we get a different measurement. If the font face was not present on the user's machine, the browser would still try to render the text for you, so it would fall back to the Arial font face, and then the measurements would be identical to the first ones. And then you would be able to find out, okay, they do have this, they don't have that, and so you can go on for hundreds or thousands of fonts and just keep on probing the user machine very fast, silently, in the background, invisibly, and get as many fonts present as you would like. So then we found, and this is what I told you about the last two levels, that there exist native fingerprinting plugins out there. So we're able to find that 2 out of the 3 companies, when they're probing the plugins of the user through JavaScript, that if they would detect the presence of a specific plugin, they would invoke it and they would call it. And we were able again to isolate that and partly reverse engineer it. And we saw that it was actually a plugin whose sole purpose was to fingerprint you better. So just a plugin that lives in your browser and just reads, it's a plugin, so it has the permissions of the process of the browser, and then it can read your registry, it can read things on your hard disk. And we saw that essentially they were reading your installation date of Windows, the name of your machine, identifiers of Internet Explorer, your IP address, and so on. And we were able to partly track it down. So we found that in some cases, when you download something from the web, like a casino client, that these plugins are bundled with them. So when you install your casino client, it silently pushes these plugins into your browser. So the next time that you open your browser and you start browsing, there is an extra plugin in there that can be used by sites in the future for fingerprinting purposes. So that was very interesting. And then we found that we also have interesting fingerprint delivery mechanisms. So essentially, we are talking about fingerprinting as a service. So we found two different models, a model where the code was pulled from the remote domain, it ran into the user's browser, it created a fingerprint, and it added this fingerprint to the DOM of the first-party page, so that when you submit a form, when you click on something, this fingerprint is sent to the client of the fingerprinters. And we also found essentially code that fingerprinted the user, sent back the fingerprint to the fingerprinting provider, and then the service itself had a session which would then internally query the fingerprinting provider for information about the device that was just fingerprinted. And the last one that I want to talk to you about is essentially proxy detection. So we found out that companies are able to essentially find out whether you're using HTTP proxies or not. And how do they do that? Well, this is the user's browser, and this is JavaScript and Flash that the fingerprinter has embedded. And we saw the following. We saw this creation of a long pseudo-random token that was created by JavaScript, and then it was used to, to make a request out on the network. So of course you're using a proxy, so your browser will just send it through the proxy, and then eventually when it reaches the fingerprint server, it will have the IP address of the proxy that was in the middle. However, then we saw this token being exchanged over Flash, and then Flash would open XML sockets towards the fingerprinting server. And surprise, surprise, Flash can actually ignore your browser level HTTP proxies and just connect directly to the remote host. So essentially now you're a fingerprinting server, you get two requests from different IP addresses with the same long alphanumerical token. And you know that, okay, this is actually the same user, this is his IP address, this is the proxy he's using, let's go on with our lives. So that is how they work, and you can read more in the paper. But now, ecosystem-like, let's talk about who is using them. So we crawled the top 10,000 sites, and we're searching for inclusions from these top 3 fingerprint providers. And essentially, this is the measurement. It's now a bit old, maybe like 8 months old. But we found 40 sites in the top 10,000 that were using them, and most prominent ones were porn and dating sites that are using fingerprinting. And our theory there is that these sites are trying to minimize, first of all, shared credentials. So you have a user that purchases a subscription and then shares the subscription with his friends. So they're trying to make sure that it's only one user per subscription by fingerprinting the environment of the user, and making sure that there are not too many environments connected to one specific account. And for dating sites, again, our theory is because the dating sites did not reply to us telling us why they use fingerprinting. Our theory is that they're trying to stop Sybil attacks. So they're trying to stop a single user having a lot of dating profiles with different attributes and just trying to game the system. And we found that Skype.com is the highest ranking website that uses fingerprinting when you're trying to log in. And we have done some new research that we'll present in Berlin in CCS in November. And these numbers are, in our research, we expanded our search, and these numbers are very much lower than what they truly are. So in the second data set, we gathered some data from WebAwet, which is this high interaction honeypot, which is used to find malicious pages that are trying to exploit your browser. And we asked the people of WebAwet to give us a list of sites that, when analyzed with WebAwet, fetched code from these fingerprinting domains, right? So we got 3,800 domains, and when we tried to categorize them using some online services, this is the categorization which we ended up with. And the first thing you can see is that, first of all, the sites belong to all sorts of categories, so fingerprinting sites, shopping and travel and business economy and entertainment and so on. But maybe the more interesting part is towards like the lower part of this graph, because there you can see that actually the top 2 categories that were found to include code from these fingerprinting providers were actually sites that were tagged as malicious by antivirus companies and sites that were tagged as spam by antivirus companies. So hold that, and then for all 3 companies, you cannot just go to their website and say, I want a free account, and you make a free account and then you start including JavaScript. No, you have to contact the sales administrator, or whatever they call them, a sales representative, and then he sits down with you and you talk with him and he gives you a specific package of fingerprinting for your needs. So the two together are a bit weird, and I just leave it to you to make any conclusions from that, or you can ask me offline. So where are we right now? presentation-wise and knowledge-wise. So we know that fingerprinting is out there, and we know that over Eckersley's prototype in 2010, there is quite a large number of new techniques. We know that large popular sites are using them, maybe not too many, but still, if you think that you have popular sites like 40 in the top 10,000, and you think of how many thousands and 10,000s of visitors these sites have every day, essentially you have hundreds of thousands, if not millions of people that are surreptitiously fingerprinted every day when going to these sites. So our question is, now that we analyzed how they work and now that we see who is using them, could they be doing more if they wanted to, or can we do better from them? So we decided to do some fingerprinting of our own. And when we were creating the fingerprinting script, we went sort of the simple way. We said, okay, historically and traditionally, the navigator object exposed to JavaScript and the screen object these two have been the two objects that have received the most attention from fingerprinters and from academia. So we decided to just, on these two objects, perform a series of everyday operations over JavaScript. So we tried to add properties to them, like to navigator, to remove properties from the navigator or the screen. We tried to change a property. We tried to, to change the object to make it non-enumerable and things like that. So we found a lot of interesting things. I will just present a few. The first thing is that the natural ordering of properties can give a browser family away and occasionally a browser version. And what does that mean? If you go to Chrome and you say, Chrome, please show me all the attributes of the navigator object. And I'm not saying developer tools, I'm saying using the construct in JavaScript for in, just listing all your JavaScript properties. And then that's what you get, like, geolocation, online, cookies enabled, and so on. If you go to Firefox and you're asking the same question, then suddenly you get a different ordering, because there are different implementations of hash tables that are populated at different times in the code, so they have no reason to match. And then when you compare it with Internet Explorer, they start actually similar with Firefox, but they quickly go another way. So you could use this as a very, very fast way of identifying specifically which version of browser you're looking at, without trusting any user agents or anything like that. So other things that we found is that every single browser, which you may know it already, has family-specific methods and properties. So for instance, Mozilla, at the time of our experiments, had a screen.mos brightness, and no other browser had a screen.mos brightness. Chrome had a WebKit start activity, and Internet Explorer had a logical XDPI. So just by querying for these extra things, you can be sure not only of the version, not only of the family of the browser, but also of the version. Because if you know that, for instance, MOS brightness was introduced in Mozilla version, let's say 14, and it's there, then you know immediately, okay, that I'm from 14 anyway to, let's say, 23 or 24, or I'm before 14. And you can use a lot of these to actually figure out exactly which version of browser you're currently running on. And then we found that the special objects, like navigator and screen, that they mutate in different ways. So if you're trying to add a property, some browsers will allow you to do it, some will not. Some will tell you that it succeeded, but it actually hasn't succeeded. Some will allow you to delete the property or change it, and so on. Then we were able to essentially use the evolution of functionality of browsers, which is kind of what I already mentioned. So this is, I'm sorry, it's a bit on the bottom, but it's almost a timeline of Chrome versions from 1 to 22, and a specific feature that is, and every two versions are separated by one single feature. So, we did a large-scale study and we discovered all of this. So if you're unsure, if you're like in version 14 or 15, you can just ask one question: is the WebSockets binary available? And then immediately you know, okay, I'm on the 14 or I'm on the 15. And then we had a lot of miscellaneous findings, and I will show you one that is silly and maybe even my favorite one. Let's go here. So, alert navigator.java enabled. Okay, so of course Java is a native function, so there is no code to show you. So what does Chrome say? It says function Java enabled, native code. Great. Let's do the same question in Firefox. Right, so it's the same thing, Java enabled new code, but look at this. So Chrome has new lines, doesn't have new lines before the squiggly lines and after the squiggly lines when the printing out that something is a native code or not. So just by doing that simple, silly test, you can find out whether you are running on Chrome or on Firefox. So that's it. Okay, so status again, it's done, it's ugly. How do users react, or how do they try to react? So we searched a bit online. So what sort of advice do people give against tracking in general? And there were like published academic research and also like underground hacking guides that were saying, yeah, go ahead and use a user agent spoofer to change the signature of your browser and confuse the trackers. Okay, so we went out and we gathered a total of 11 such user agents. At the time of our experiments, they were used by a bit more than 800,000 users, and I think now there are more. And the question is, how do they stand up against fingerprinting? And we did not do any of the tricks that we had found in the earlier section. What we did is we just enabled it. We had a look at the navigator object, the screen object, and the headers that go out towards the server when these things are enabled. So the thing is that unfortunately all of them had one of the following. So they had an incomplete coverage of the navigator object. So the extension will go there, it would change the navigator.useragent, but it would forget to change the navigator.platform. So suddenly you had an Internet Explorer 8 that runs on Linux. Yeah. Then you had impossible configurations, kind of similar with the first one. So you had an iPhone, supposedly an iPhone, that had a screen size of 2,000 pixels. Again, this doesn't work. And also, a number of them were forgetting that the user agent is communicated through the JavaScript property as well as the HTTP header. So they would change one, but they wouldn't change the other. Now, you may think, okay, so we're back to back where we started, but that's not true. So the paradox with privacy is that if you're trying to be private, if you're trying to be anonymous, but you're not doing it perfectly, you're worse than when you began. So, and since I'm Greek, I like to use Greek words. So this is an iatrogenic problem, which means that it was created by a doctor during examination. And the problem is that when you install these, a user becomes more visible and more fingerprintable than before. And we can look at this as a Venn diagram. Imagine that the browser's fingerprintable surface, is all this big white box, and each extension is running here, and let's say that this common part here is the navigator.useragent, which everyone changes. But its extension author is trying to do more. So, they're changing a bit more of the navigator object. And then another one is saying, oh, but the screen can also reveal things. I'll go and change things there. So every single extension tries to cover as much as possible. But of course, they cannot cover everything. So if you know about these extensions, there are not all that many to begin with, then you can say, okay, is extension A present? And remember that in browsers, you cannot ask them for a list of extensions. You can ask them for a list of plugins. So you can only find out extensions by the side effects. So if you know what is specific to extension A, you just go and you search for that weird specific thing of extension A. And then you say, okay, it is extension A, or it is extension B, or it is extension C. And the thing is that you start, let's say, from a user base of Firefox users, let's say hundreds of millions, and you go down to the user base of an extension C, which is 3,000. So you have de-anonymized like 3 or 4 orders of magnitudes just because the user had installed a specific extension as a way of protecting himself against fingerprinting and against tracking. So to conclude, fingerprinting is very much a real problem, and I wish I had an answer for you today, but I don't. So the best answer that I can give you is stop trying too much. The more you look like a native, just a vanilla Firefox or Chrome out of the box without weird extensions installed, the more you can blend in a larger crowd of browsers. So, and as you saw, it is really, really hard to make browsers seem identical simply because they're huge beasts. And you should not be using browser extensions for privacy reasons. If you're using it for your bank because it only allows you to visit your bank site with Internet Explorer, then you have to remember to enable it and disable it before, because you're hurting yourself if you're leaving it there. And connected to all of these, the long-term solutions, just from my point of view, it's doubtful that they will be purely technical ones, simply because it is too difficult. So I think that there will probably be some legislation required, like we do now in cookies, that you would say, please be aware that you're being fingerprinted. Are you okay with this? And so on. So thank you very much for your attention, and I will take any questions that you may have.
So let's try to do it.
The question is simply what if you simply disable scripts, are these fingerprinting things run in scripts
Partly.
from specific sites? So
Right.
if you just block them,
It is partly. So there are two things that I want to say. The first thing is that normal users don't use NoScript. So that's one thing. The second thing is that there's a study from Microsoft Research in, I think, NDSS 2012, where they showed that if you have a machine that doesn't move a lot around, like maybe a laptop that you only use at work or a desktop machine that takes an IP address in specific ranges and doesn't change, then you can actually fingerprint you quite well simply by checking at the user agent that you send from your header and the IP address. So it's not that you install NoScript and all the problems go magically away.
Okay, more questions? Yep.
One of the problems you mentioned with the extensions to hide the fact or your fingerprint from other services was to go mesh in with the crowd to be more vanilla user. What about offloading the whole environment that you're browsing in? Like not use a proxy, but actually use a completely different machine to set up your browser environment.
So you mean some cloud instance that would...
Yeah.
I think that would be a step towards a good direction. Yeah. If you can homogenize an environment and have a lot of different users go through that homogenized environment, then you're indeed helping.
I think I saw.
What about a plugin which detects fingerprinting? Then the user would have the choice. This website tries to spy me, I don't like that, I will go away and never come back.
Right. So there have been some efforts more in the protection side. So I will try to give random answers when I'm answered and so on. But as we showed, this doesn't work. So the work that I mentioned that we'll present in Berlin in November, we used something like that. So we used a crawler that was fingerprinting sensitive. So we took some heuristics that when, for example, our fonts were inquired, then maybe we should look this later for manual analysis. So I think that's definitely a good thing. But then you may run into the usual, cat and mouse. So you check for 3 signatures, the fingerprinting companies evolve, and then you cannot catch them anymore. So you go on and you have this sort of arms race. So I think it's a good, first step, but it's towards a longer road with legislation and all of that.
What about request policy, which inhibits requests to third parties?
So are you talking, for instance, about CSP in some way?
Now there is a Firefox plugin. It's request policy, which is similar to NoScript, but it does not. Its purpose is to allow or disallow requests altogether.
Okay. So I think you could, you could do that even just by going to your, your local DNS and say these 10 domains, please resolve them to, to localhost, and this will work. But again, this doesn't stop the fingerprinting companies of registering a new domain with a new host and starting this. So for me, it's a bit reminiscent of the malware issue. So you create some signatures, they evolve, you try to adopt, they evolve. So that's why I think that law is required in that, in that process.
Do any add-ons like Flash bypass proxies in any time?
Flash, yes.
But also other plugins, they also do it the same way, or it's
so-
specific of Flash?
So I haven't looked into that. The only thing that I can tell you is that all 3 companies are using Flash. One of them looked like in the past they were using Java, but the Java applet was no longer available on the servers. So it seems to me that Flash is still a very big part of the market. So, if Flash works, they focus on Flash, but I could not tell you, like another range of plugins, whether you can do this or not.
I don't know whether this was asked before because I just stepped out, but regarding the proxy, there are variables normally you could query for on the server side. X HTTP underscore forwarded for, then I think four or five variables which you can just probe, and then you get the real IP address behind the proxy.
Well, this is more, I think, depends on what the proxy does. So if you have a proxy, if you have, let's say, your own proxy that you set up to do not include any new headers, then you will just have a connection that looks exactly like the browser sent it, but it has a different IP address. So I don't think you can use these extra headers to depend all that much on them, on their presence or not.
Okay, but if you're that far, I mean, you're probably in a very good company network, and well, then it's maybe difficult to track anyway.
So if you're in a very large company that has, let's say, 10,000 of identical PCs for their workers, then and you're locked down, so you cannot install new plugins and so on, then fingerprinting is not a problem for you right now. However, if you can customize your own environment, or if you're any of your home users, laptops, desktops, tablets, and so on, then you run into the issues of identification.
Okay.
Further questions?
Yes.
What about the browser's privacy mode?
It doesn't matter, because when you switch to privacy mode, your plugins are there. So your extensions are not there, but your plugins are there. Your IP address is there. Your cookies are not there, but they were never relying on cookies to begin with. So it's the same.
More questions? So I think I have a final one for you.
Okay.
I do know that some of these analytics scripts, they went into a phase where they added additional functionality, convenience that the web developers started to use. So if you blocked the scripts, the whole site wouldn't work anymore.
Right.
Did you see the same thing with fingerprinting scripts?
No. So at this point, it seems that the site can work if you block the script. However, we saw, for instance, that, let's say, a very straightforward solution against the flash fingerprinting, like in modern browsers, you have the click to play. So if you're hiding the flash in an invisible iframe, then the user will never be able to click it, right, and play with it. However, this really just means that the fingerprinter and their clients need a better, tighter integration, because then I can have something in the flash thing that I need to run, and then I will render the site properly. So then you will have to click on it, and as part of the normal functionality of the flash object or whatever is used, I will also do my fingerprinting. But right now, it seems that you can block them without side effects.
Okay, so let's thank Nick.
Thank you.